About the company. So MetGen is a biotech company from Finland that supplies industrial enzymes designed for harsh industrial conditions and tailored to the customer-specific needs. We address the markets in pulp and paper, packaging, and biochemicals, including biofuels, but also the renewable materials such as renewable plastics as well. The industries that we target at this time specifically are pulp and packaging and biorefineries. In the pulp and packaging side, we aim for reducing the production cost and create energy savings. At the same time, even more importantly, we try to get to product quality improvements. Also, the process runnability is one of the main areas that we address with the Enzymatic solutions. Almost as a side product of all of this, there's an improvement in sustainability. Enzymes are very ecologically friendly solution. On the biorefinery side, we try to address the technology cost of enzymes that many people claim that is too high at this time. And we'll try to come up with tailored solutions that are so well suited for the customer process that not an overdose of enzymes is needed. Furthermore, we try to get to the same or higher sugar yields while addressing harder biomasses, wood-based biomasses with a lot of lignin, and also those biomasses with a high consistency, meaning that there's a high dry matter content to them. So let's have a look what we have out there at this time. For example, in recycled fiber, we have a product family called Rila, which is designed to give you more improved strength properties for the fiber. So the enzyme mix is designed to clean the fiber, fibrillate it without cutting it, and providing more strength properties to the process. Now, how does a mill use this? There's at least 3 ways that you can do that. You can reduce the raw material cost and run with a lower grade raw material with still having the same strength properties for your tissue making. This is a cost reduction. Or the alternative is that you can have the same mix that you had before or more virgin fiber and use the strength addition in order to get more speed to your production and more productivity out of the machine. This comes also with the improvements in dewatering on the drying section of the machine. Furthermore, there's the energy saving aspect of it. So in the actual paper mills where we are running this at this time, there are, in one specific case, there are 3 refiners, and once they start using enzyme, they can just drop two of those refiners out of the equation and just handle the whole process with 1 refiner instead of the 3 that they needed before. So this is a significant process improvement. One thing that the customers here are very interested about is that the enzyme allows them to have less breaks on the machine. So this also improves the productivity quite a bit. Furthermore, in the chemical and semi-chemical pulp, we have a product family called Cobon, which does basically the same thing in a different application. So it's a completely different enzyme mix, but once again, we're addressing the strength properties of the pulp. And main goal here is to improve the process runnability, avoiding those breaks on the board machine. But at the same time, we do save a lot of energy here as well. And there's additional benefits as well. In a particular case, in a fluting application, the product is also much lighter coming out of the process because some parts of our enzymatic product are actually addressing the lignin in the circulation water. So there's a lot of additional benefits there. And these benefits lead all the way down to the effluent as well, where you have a lower COD and so forth. So there's a lot of additional benefits and sustainability aspects to this as well. Another one of our products, a completely different one, is Metzyme Ligno, which is designed to save energy in TMP, thermomechanical pulping, and reject refining. So this is an enzyme that is designed to break the lignin network and reduce the energy needed to refine the chips to pulp or further refining of the reject. In these applications, the refining is very energy intensive, and our enzyme actually addresses that quite a bit. In the mill scale, industrial trials, we have achieved 10 to 15% energy saving with the use of enzyme in thermomechanical pulping. So moving on to the biorefinery side. So there are a lot of people who are offering solutions to get to the cellulosic sugars. They're called hydrolytic enzymes. They're usually cocktails of cellulases and hemicellulases. Well, our take on this is that there's no magic bullet that can actually cover all the pre-treated different feedstocks. There are a variety of different feedstocks. There are dozens of different pre-treatment methods, all creating different substrates that are going to be handled in different processes. So enzymes really need to be tailored for this. Our approach in this is a tailor-made drop-in solution. What MetGen does is that we study your process, we study your substrate, and we will create an enzyme blend that works just for that. Now, what is the benefit of all this extra work? First of all, we can avoid overdosing of the enzyme. So if you just take a generic cellulase or hemicellulase complex, you will end up overdosing because that enzymatic solution is not designed for your substrate. So first of all, that's lowering the enzymatic cost, the total cost of the technology there. Furthermore, if you do a good job selecting the booster enzymes to the cellulases, you will actually have a better chance of addressing wood-like substrates as well, not just the bagasse or the corn stover that are more in the core of the typical commercial solutions today. Also, one of our key focuses in our work is to allow our customers and partners to achieve higher consistency biomass. Why is this important? Well, typically when enzyme performance in a lab scale is demonstrated, one uses 10% consistency, 10% dry solids in the material. Now, this bears very little relevance in an industrial scale. Building a factory for that consistency is twice as big in comparison to 20% consistency. And this is actually a limitation for most of the conventional hydrolytic enzymes. They start to be inhibited in those concentrations, especially if we're talking about wood-based raw materials. Now, this is where MetGen focuses, to allow that improvement also on the capital investment side and operational cost of the facility by addressing the dry matter content and allowing higher dry matter content of the substrate. But it doesn't end in getting to the sugars. The sugar platform is an excellent starting point for further getting to higher value addition chemicals or precursors of those. In MetGen product families, Metzyme Pureco represents everything beyond sugars, and here I wanted to bring out one example that we've been working on. So we identified a value chain together with our partners in a European Union sponsored project called RETAP, and the value chain is from wood to bioplastics, and our collaboration partners in this particular project are Secap from Sweden and Avantium of the Netherlands. So there is a chemical process on Avantium's side that allows fructose to be converted into polymer that can be used in plastic packaging, actually better material than the PET used in the bottles today. This has raised very high level of interest in the packaging industry and the companies like Coca-Cola. But the thing is, the enzymatic solutions out there didn't allow making this from wood, because one of the most common enzyme groups, glucose isomerase, is mainly targeted for the food and feed, well, mainly food industry. And as such, it doesn't work in the lignocellulosic hydrolysates. It's inhibited by everything that is in there, the other sugars that will stuck into the active site and all the lignins and phenolic compounds and all that. Now, what MetGen has now created is a glucose isomerase for these technical specifications, a molecule that can actually withstand the harsh industrial conditions needed to make the fructose for plastic production. So we are actually now having an enzyme that can be put straight into the liquid phase of the hydrolysate without any purification, and will do the conversion for you. So that's a pretty neat thing. And it's one small step in a big value chain that allows people to have wood-based plastic packaging in the future. I wanted to bring in the wastewater application as well, because even though we're focusing on lignocellulosic biomass, all these industries actually have to handle the water as well. Now, A lot of the problems that our customers and collaboration partners have are related to the same substrates that we are addressing in the actual process with enzymes. So we do have solutions for COD reduction or the micropollutant elimination as well. So, for example, here I can mention that a hormone-like compound bisphenol A is something that we can address very well if that happens to be a problem. And furthermore, in the biogas production and the wastewater treatment plants, our enzymatic solutions can really dramatically help the microbiological action in the biogas facility or the wastewater treatment plant to do a better job and improve the capacity of those facilities, improve the productivity, and reduce the waste created. So why are we looking at lignocellulosic biomass, and why are we focusing on the pulp and paper side? Well, that is because the value chain in pulp and paper side is possessing the biggest volume and mass of lignocellulosic biomass. They own the value chain from forest to the consumer products. There are new value chains emerging, some of these within the pulp and paper as well, but some independently, like the plastic bottles and so forth. Our vision of the future is that these value chains, once the technology is mature, will gravitate towards the biggest existing value and supply chain being the pulp and paper. So we truly believe that in the future the pulp mills will be integrated by refineries in a true sense of the word with products like plastic bottles coming out of them on top of the paper and the packaging materials and the admittedly fancy things like nanocellulose and everything. So we work hard in order to address the current issues that these industries have with novel solutions, but also we'd like to be the pioneers and show the industries the way, what is out there, what can be done next. And how do we do that? So we have created a standardized technology platform to addressing these customer challenges. Now, for simplicity's sake, I just say that this is a very neat way of doing a very, very hard thing in a relatively fast and an easy manner. So what we can do with this standardized method, and this is compiling all the expertise in biotechnology and customer segments that we have with the process technologies, capability to scale up, and the production strains that we have together in a way that allows us to come up with even a completely new molecule, completely new enzyme that matches the customer challenges, whether it's high pH or high temperature specification or requirement by the process, into an industrial solution that comes in 1,000 liter IBC container together with our service technician to provide the application service and help at the customer facility, all within 1 year's time. If we have the enzymes already and we just have to optimize an enzyme mix for the customer, then we're talking a much shorter time. And all these products that you just saw are pretty much on the shelf, so then we're talking about 2 months' time. So MetGen is all about tailoring the solution for the customer and making enzymes that actually work in the application, avoiding that extra cost and breaking that illusion that enzymes are too expensive to be used in manufacturing industry. I thank you for your attention, and I'm happy to entertain a question or two. We also have a booth over there, roughly 50 paces away, so I'll be there all day today and tomorrow, so please come by and have a chat.